subarachnoid space by median and lateral apertures. Figure 11.26, take a look at that. You have these lateral ventricles coming down to third ventricles, to fourth ventricles, so know where those ventricles are. Then we look at cerebrospinal fluid. This is produced from the blood in the choroid plexus of each ventricle by ependymal cells. Remember the ependymal cells we looked at under neuroglial cells? This green little square cells. It's actually not green in real life, but from our picture. So those cells produce all your CSF, cerebrospinal fluid. It's very easy to make it. Well, no. I mean, you know, if you have to make it, and you have the salt, sodium, there goes out, sodium chloride, and you have the water following by osmosis. So that's all you have in your CSF. Some proteins too come in there, but nothing more. So it's not like your blood cells, where blood where you have lots of other cells in there. So CSF is not all that fancy. So you just have few things in there. CSF is produced in your ventricles, actually in your lateral ventricles part there, and it moves around to your third and fourth ventricles, and then goes down to the subarachnoid space, all over in your brain, and from your space there, it joins into the venous system, and that's how the CSF, even though if they say it's made approximately 0.4 mils of it is made per minute. So the rate of making the CSF has to be equal to the rate it's going back to the blood. There are problems you can have when it does not happen. One of the diseases you get is hydrocephalus, and you see sometimes babies are born, or babies with really big head. Hydrocephalus can kill them. That the reason is you have this CSF, instead of it being going back to the blood, circulating around, something is blocked somehow, so it just stays up in the ventricles, and the ventricles have all the CSF, so you have lots of pressure, hydrostatic pressure, and the head looks bigger. And so people can die. But if you do get treatment, they usually try to take off all the water from there. But that can be dangerous because you can introduce diseases like it's very sensitive, like bacteria can somehow go in. But that's the only way you do treat them, I think, so far. I haven't heard of any other ways. So that's a little bit about the CSF movement. CSF, when you have it in the subarachnoid space around your brain, from there you have what we call arachnoid granulations. That passes it down to the blood through the dural venous sinuses. So that's how it goes back to the blood. Blood supply to the brain. Brain requires tremendous amounts of blood to function normally. A high metabolic rate, and brain cells cannot store high energy molecules. Only about 2% of body weight is your brain, but it receives about 15 to 20% of the blood pumped by the heart. So the blood-brain barrier is formed by the endothelial cells of the capillaries in the brain. Blood-brain barrier basically limits what substances enter brain tissues and what not. It's kind of important when you look at this in like making drugs as well. One of the diseases is Parkinson's disease. The thing that does not work for them is dopamine. So you can't just give dopamine into them, because dopamine won't go into the blood-brain. It won't cross the blood-brain barrier. So what they do is give L-dopa, levo-dopamine, that can cross the blood-brain barrier. So it's kind of important to know a little bit about the blood-brain barrier when you're thinking of making things like drugs and other things. Let's see. Okay, then we go to cranial nerves, and we end the chapter learning about cranial nerves. You have a figure 11.28, that shows all your cranial nerves. I would say learn this figure well. So in case I give labeling within the multiple choice, you'll know how to answer it. So you have cranial nerve 1, 2, 3, 4, all the way to cranial nerve 12. Learn all the 12 names, learn all of their functions and consequences of lesions to nerves. That is on figure 11.2. I'll expand on that in a while. But some of the nerves you're looking at in this figure are your olfactory nerve, very common nerve for smell You have the optic nerve, that's for vision. Oculomotor nerve does a lot of eye movement, pupil diameter control and all that. Trochlear nerve, again, a lot of those eye movements. Trigeminal nerves are usually used for chewing. Very, very important in, like, dentists, whenever they have to put anesthetics, they find your trigeminal nerve. They actually, not the trigeminal nerve itself, it separates into your inferior and superior alveolar nerves. That's where they inject your anesthetics and to numb you down there. So, that's there. Abducent nerve, that's also for eye movement. A lot of those. Facial nerve, such an important nerve. A lot of these nerves also are involved in tear production, making you cry, all that. Taste, facial expressions, all these movements I'm doing right now, facial expressions as well are involved in here. Salivation and all of that. And then you have the vestibular cochlear nerve that's involved with hearing and balance. Glossopharyngeal nerve involved with taste, salivation. Vagus nerve got to do with taste a lot. So look at all those nerves and know the functions in the table 11.2. Also know what are the consequences to have a lesion to the nerve. For example, if you cut the nerve, if there is a tumor in the nerve, what happens? An example is olfactory nerve. If something is blocked over there, you can't smell anymore. Inability to smell. Optic nerve, anything happens there, blindness, happens right there. So those are how you study those things. Facial nerve, usually call that facial palsy, which is like paralysis of the face, if that nerve is damaged over there. So know all of these nerves and function and consequences to lesions. And we have finished the chapter, so good luck studying for your next week. You have 2 quizzes, study for that, and then we'll have a quiz over this chapter week after. Enjoy the rest of the day and the weekend, and I will see you in class soon.